Curve fitting with linear models. Our objective is to fit scatterplot data using linear models with and without technology, as well as use linear models to make predictions. Why learn this? Anthropologists can use linear models to estimate the heights of ancient people from bones that the anthropologists find. Let's start with some vocabulary. A regression, the statistical study of the relationship between variables. A correlation, the strength and direction of the linear relationship between the two variables. Your line of best fit is a line that best fits all of the data. And the correlation coefficient, it's the R value, is a measure of how well the data set is fit by a model. So, this is a positive correlation because it has a positive slope. And this is a negative correlation and it has a negative slope. The third one has relatively no correlation. The data is too far all over the place. Let's look at a meteorology application. Akron, Ohio, and Wellington, New Zealand are about the same distance from the equator. Make a scatter plot for the temperature data. Identify the correlation, and then sketch a line of best fit and find its equation. Alright, so step 1. We want to plot the points. So we have plotted all of our points. So Wellington's temperature is on the y-axis, Akron's on the bottom, and each point is plotted. Step 2. We want to identify the correlation. Basically, it's asking, is the correlation positive or negative? Well, since the graph is going down, this is a negative correlation. Here, let me change colors on that so that way it doesn't look like part of one of the questions. Okay, so you've identified the correlation. Now step 3 is to sketch a line of best fit. So to do this, you want to draw a line that splits the data as evenly as you can above and below. So you want a line that will best fit each one of these points as closely as you can. So step 4, once you've finished drawing your line of best fit, is to identify 2 points on the line. So you'll notice that there are 2 points that are darker, and one is labeled 3070 and the other 8052. So those will be the 2 points that we're going to use. So we have 3070 and 8052. Both of those points fall on the line, and they end up lining up nicely, so you might as well pick a point like that instead of like 31 or 72.5. So try to pick nice points that fall right on your grid. Now, let's find the slope. Once you have 2 points, it's not too bad to try to find your slope. So we have the change in y over the change in x. And we simplify. We get 18 over negative 50, which is about negative 0.36. Alright, so step 6. Use point-slope form to write the equation of the line. I'll accept either using your 1850s or your negative 0.36. And the equation for point-slope form, if we recall back, is y minus y1 equals m times x minus x1. So we have y minus 70, because we're just going to pick one of the coordinates that we used. We don't need to use both, equals negative 0.36 times x minus 30. And that's that one. Alright, so now let's look at some properties of the correlation coefficient. So r is a value in the range of -1 to 1. So if r equals 1, the data set forms a straight line with a positive slope. So basically that would be a nice, every dot lines up on the line. So the closer the data is to 0 for the r value, the closer it is to having no correlation, meaning the data is kind of all over the place. If you're going more towards -1, if you had it exactly -1, it would form a nice perfect straight line. Every piece of data would line up on that line. So notice how as we get closer to either 1 or -1, the data is closer to being a straight line. Whereas the closer it is to 0, the more spread out and all over the place the data is. Alright. You can use a graphing calculator to perform a linear regression and find the correlation coefficient r. However, you might have to turn on the diagnostic. So basically to do this, you're going to go to second and then hit 0 with the catalog above it, so second catalog. And then go down until you see diagnostic on, and you're going to just hit enter and you'll turn it on. So now that it's on, we can utilize our calculators to help us solve an anthropology application. So anthropologists use relationships between the height and length of a woman's humerus bone, the bone between the elbow and the shoulder, to estimate a woman's height. Some samples are shown in the table. So, humerus length. So that's our 35, 27, 30, and so on. And our height is 167, 146, and continues on. So step 1, we want to make a scatter plot of the data with humerus length as the independent variable. Since humerus length is the independent, our independent variables are our x values. So x, y-axis. And now we're going to use our calculators. So there's a couple of things that one might need to do first. So let's start by hitting our y equals key. And when we do so, we want to make sure that when you see your screen, at the top of your screen, you have plot 1. You want to make sure that that is highlighted. And then that all of your y values coming down are blank. So clear all of your y values and then highlight your plot 1. To do so, click on it and hit enter. Okay, so that's step 1. Step 2. You're going to hit second and then your y equals because you want your stat plot. And when you do so, you're going to select the plot 1 because it should be on now. So select that first one and then you should have a screen that refers to, it has the on button is selected, and then below that you have type. So you want to make sure the one that looks like a scatter plot is selected. So that would be the first one as you go across of your 6. And then your list, you have X list, Y list. Make sure that says L1 and L2. So now that that is all set, we can now hit our stat key. So this is our third step here. We're going to hit our stat key. And when we hit our stat key, we're going to select edit because we're trying to edit a set of data. So we want to insert the data shown above. So your L1 is essentially your X because that's what you've classified it as here. and your L2 will be your y values, which is also what you classified it as in step 2. So under L1 and L2, you're going to insert that data. If there's already data there, just go up and select L1, hit clear and enter, and your whole list will become cleared. And then insert your data. So your 35, 27, and then just keep going. And then for your L2, you're going to have your 167, your 146, and keep going in order all the way across your list. So now that you have done that, you can now graph. So hit the graph button, and when you hit the graph button, you'll have a graph that looks like so. You won't see the formula written up here, but you'll have a graph as such. And now you might want to calculate certain pieces of data. So we're going to go to stat because we want to find the correlation coefficient. So you're going to go to stat, and then when you click on stat, you're going to go over to calculate instead of your edit, and you're going to look for ln reg, and in parentheses next to it you'll have ax plus b. So you're going to select that one and hit enter, and then it will show up on your beginning screen, and just hit enter one more time, and you'll have a screen that looks like this. So in this screen, you're seeing your slope-intercept form. So your A value is your slope, your B value is your y-intercept. So if you look, you're going to have y equals 2.75x plus 71.97. So that's to interpret the slope. Your slope is 2.75. So now we want the humerus. If the humerus was 32 centimeters long, so what would be the height? Well, there's your input value, so you're going to input 32 in for x and get an output value. So simply substitute 32 in this case, on this example here, they use the L, so substitute that in. So when you do 2.75 times 32 plus 71.97, just so you know we substituted in 32, you end up with about 159.97. So essentially about 160 centimeters. And that ends our lesson on curve fitting with linear models.